Solve for x. In part A, we're asked to solve e to the x equals 10 for x. So what we notice is that the first thing that we're doing is exponentiating x base e. So we need to recall that to undo exponentiation base e, we need to take the logarithm of both sides base e. In other words, take the natural logarithm of both sides. On the left-hand side, the natural logarithm undoes the exponentiation base e, and that just leaves us with the exponent, which is x. The right-hand side, we just leave that as the natural logarithm of 10. So our solution to the equation is x is equal to the natural logarithm of 10. Now it's good to check and make sure that your solutions work. You can use your calculator to do that. In this case, we would enter the natural logarithm of 10 as our answer, and then store that as our variable x. We can see that x is approximately 2.303. We want to make sure that when we substitute this value for x into our original equation that it checks. So let's evaluate e raised to the x and make sure that it comes out to be the number 10. We see that e raised to the x does evaluate to the number 10, and so we've solved the equation correctly. For part B, we have the equation 10 to the x is equal to 3. It's a similar type of equation, but in this case we have exponentiation base 10. We're exponentiating x base 10, so we need to undo that by taking the logarithm of both sides base 10. In other words, take the common logarithm of both sides. On the left-hand side, the common logarithm undoes the exponentiation base 10 and leaves us with the exponent of x. On the right-hand side, we have the logarithm of 3. And so x is equal to the common logarithm of 3. That's our solution. Let's double check and make sure that it works. We store logarithm of 3 as x. The value is approximately 0.477. We go back to our original equation and we evaluate 10 raised to the x, and we check to see that it comes out to be the number 3. We see that 10 to the x is the number 3, therefore we've solved the equation correctly. For part C, we have the equation 2 plus 4 to the x is equal to 7. This equation is a little bit different than what we had in parts A and B. So what we'll do is first of all subtract 2 from both sides to change it back into the form of A and B. So we'll first of all take away 2 from both sides, and that gives us 4 to the x is equal to 5. On the left-hand side, we have exponentiation base 4. So what we'll do is we'll take the logarithm of both sides in order to undo that exponentiation. Now we could take the logarithm of both sides base 4, but in our class we typically use natural logarithms and common logarithms, so you can take your pick. I'm going to go ahead and use common logarithms. Take the common logarithm of both sides. On the left-hand side, the common logarithm is base 10, and we're exponentiating base 4, so these two do not undo each other. However, we can use a property of logarithms to simplify the left-hand side. That property says that the logarithm of a power is equal to the exponent of the power multiplied by the logarithm of the base. So in this case, the left-hand side becomes x times the logarithm of 4. So we have x multiplied by the logarithm of 4 is equal to the logarithm of 5. X is being multiplied by the log of 4, so to undo that multiplication we can use division. Divide both sides by the log of 4. The solution to our equation is x is equal to the logarithm of 5 divided by the logarithm of 4. We can use our calculator to check, just like we've done previously. First of all, store the logarithm of 5 divided by the logarithm of 4 as x. We can see that the approximate result is 1.161. And then go back to the original equation and evaluate the left-hand side to check and make sure that it is equal to the right-hand side. We see that 2 plus 4 raised to the x is 7, which matches our original equation, and so we've solved the equation correctly.